In this video, we're just going to get some practice doing antiderivatives and integrals. All right, so now we know the fundamental theorem of calculus, which says if I want to find the exact area under my function, I take its antiderivative, and then I just plug in the two bounds. All right, so in this video, we're just going to kind of put together the two videos we had, taking antiderivatives and then applying this fundamental theorem of calculus. All right, so here's the first example. We want to find the exact area of x cubed minus x squared plus x from 0 to 1. All right, so there's step 1, take antiderivative. And right now, the only real antiderivative strategy we have is to do the reverse power rule. So that's what we're going to do. We add 1 to the exponent, divide by the new exponent. Minus, we add 1 to the exponent, divide by the new exponent. This is x to the first, so we have x squared over 2. All right, so that is my antiderivative, and I want to evaluate it from 0 to 1. So remember, that kind of straight line up and down means I'm about to plug in these numbers. It's kind of a record-keeping thing. You definitely want to write this on your paper so you kind of know you just took an antiderivative, and now I want to plug stuff in. First thing I do is plug in 1. And then I want to subtract when I plug in 0. And a lot of times for these ones, we use 0 because one of the terms just completely goes away. Everything there turns into 0. This gives me 1/4 minus 1/3 plus 1/2. And we might as well just finish the problem, get a common denominator. So it's 9 minus 4 is 5 over 12. All right, so that's our final answer there. All right, again, process. I didn't actually write down the second. Take antiderivative, plug in, balance. And I guess step 3, simplify. All right, so those are our process. Always remember to take the antiderivative. The biggest mistake students tend to make is just plugging the numbers into the expression you're given, but you have to find the antiderivative first. The second most common mistake is plugging the bottom number first. So we plug in 1 first, and then we plug in 0. All right, here's another one. All right, integral from 2 to 4 of 5x minus 2. All right, first step, antiderivative. So 5x to the first, can we go 5x to the second over 2? All right, 2 is 2x to the 0. So I'm going to, okay, because x to the 0 is just 1. All right, so that's the same as 2. So I'm going to add 1 to the exponent, 2x to the first, divided by the new exponent. And I'm going to evaluate that from 2 to 4. Now I plug in 4 first. 2 times 4. All right, so that's when I plug in 4. Subtract when I plug in 2. Okay, and again, just to be careful with this negative that's kind of sitting around in the middle, I kind of separate each of them and simplify them separately. So this one, 5 times 16 is 50 plus 30, 80. 80 divided by 2 is 40, minus 8. And this is 20 over 2 is 10, minus 4. 32 minus 6 is 26. Right, so again, just being careful when you're simplifying. I think it's a really good idea to just get in the habit of simplifying this whole thing to a single number, simplifying this whole thing to a single number, and then subtracting at the end. You're more likely to, or sorry, less likely to make a mistake with negatives if you do it that way. All right, next one, integral from 4 to 9 as square root of x plus 1 over x. This one looks complicated, but you can always do that kind of initial step of thinking about these as exponents. And I just realized I made a mistake. We can't do this one yet, so let's change it to 1 over x squared. So that means this is x to the negative 2. If you want a fun little exercise, figure out why we can't do it if it's 1 over x yet. But I take my antiderivative. And I'm going to evaluate it from 4 to 9. Right, sometimes it's helpful to simplify your expression before you start plugging in numbers. All right, I'm going to rewrite this in a little bit nicer way. This is, let's say, 2 square root of x cubed over 3. All right, so the dividing by the fraction same as multiplying by its reciprocal, and I just rewrote 3 halves as square root and exponent, and this is minus 1 over x. Now the next thing is just plug in 9 and 4. So that's plugging in 9. I subtract. I plug in 4. And this could be a little tedious. 9 cubed is a big number. What's its square root? This is 27. Yeah, I'm kind of separating each one. This is 4, 16, 64, 6. No, sorry, 8. 8. 2 times 27, it's 9, 18. And whatever, this video isn't the most important time to just find a bunch of common denominators and everything, but keep going from here, find some common denominators, put things together, get your final answer. But we did the important new calculus stuff of doing the reverse power rule, doing a little bit of simplifying so we can kind of see exactly what we're plugging stuff into, and then plug in the top bound first, bottom bound second. All right, so that's the basic idea. But again, you can finish this problem. And here's one for you to try on your own. I find the exact area, all right, of this integral. And I'll show you the answer in 3, 2, 1. All right, when you get your antiderivative, you add 1 to the exponent. Remember that 1 over x squared is x to the negative 1/2. I rewrite it doing some simplifying, and you try to plug in 0 and negative 2. I did make one mistake. You can't actually plug in 0 because you get 1 over 0, and that is like infinity. But the basic idea, you have plug in 0, plug in negative 2, simplify as much as you could. This one, I just made a mistake. You can't actually simplify down to a final answer. That's really important points. All right, use the reverse power rule to find your antiderivatives. Right now, the only one we can't do that with is 1 over x. So again, think about why that's not possible. All right, plug the bounds into the antiderivative and making sure you plug in the top bound first. And from there, it's just a bunch of simplifying. And I actually talk more about simplifying later in the class as well.